as for the non-steroid estrogens, okay, they are typically the derivative of trans-stilbene. This is trans-stilbene. Trans-stilbene, somehow the structure of trans-stilbene, the structure and the three-dimensional shape of the trans-stilbene somehow resembles that of estrol or estradiol. Okay? However, here we have two aromatic rings instead of one. No, the most important non-steroid estrogen agonists are hexastrol, and dienestrol. You see, in the case of hexastrol, okay, the trans-stilbene molecule is somehow.
This is the one hexagon.
Yeah.
Indeed.
You see, somehow modified since two more carbons were introduced into the middle part. This way, there is a chain composed of 1, 2, 3, 4, 5, 6 carbons. Okay. And two aromatic rings with phenolic hydroxyl on both. And here we have one asymmetric carbon, and here we have another asymmetric carbon. However, as it is stated here, it is the mesoform which is the most active form of this compound.
Meso is most active?
Meso is the most active.
But if meso has one right hand, one left hand, they cancel each other?
Exactly.
And in this case, the activity is higher in any case?
Yeah. Since, what is interesting, you know, so since this compound is very much the same as, I mean, from stereochemical point of view, like tartaric acid.
Yes.
You remember? Yes. Since if you consider the substituents of one of the asymmetric carbon and the other asymmetric carbon, okay, you will see that the four different substituents, hydrogen and the rest, ethyl, phenol, hydrogen and the rest, is very much the same. So in this case, there is an internal plane of symmetry in the molecule, and this internal plane of symmetry reduces the possible stereoisomers, and that's why there is a dextrorotatory, a lever rotatory form, and the mesoform. And in case of the mesoform, it is optically inactive. The other thing is dienestrol is somehow similar to hexastrol. However, in this case, there are two double bonds. You see, this is diene, okay? And the two double bonds make a definite shape of the molecules and definite stereochemistry. Okay? No. And here is the third one, which is also a trans-stilbene derivative. This is diethylstilbestrol. No. What are the estrogen substitution? What are the risks? The risks of estrogen substitution. First of all, thromboembolic events, which is very common, and that's the main risk of estrogen substitution. Blood stone, no, bile stone, formation of bile stones, yeah, hypertonia.
These are the side effects?
Yes, the side effects. Possible risk, not necessary, but effect. Yeah. Endometrium.
Hypertonia means blood pressure.
High blood pressure, exactly. Kind of cancer of endometrium, and kind of cancer of the English. How to say the, okay, later I will try to.
Dargan means cancer.
Dagenham means,
And Emlo means?
Amlo means Amlush, you know. I mean, Amlo is this part.
MLS is Philip.
This part.
Chest, you mean?
Not the chest, but
Lung?
not the lung.
Mammalian?
Yeah, mammal. Yeah.
Breast cancer.
Yes, breast cancer. Yeah, that's it. Breast cancer. Yes. So that's it. No, so breast cancer. So these are the risks. And this is very common, you know, since after menopause, each woman and each medical doctor should make a decision. Go on substitution, I mean estrogen substitution, or don't go on estrogen substitution. So
These are the side effects of all of the non-steroid or just these?
No, it's all of them.
All of them.
All of them. All of them. Yeah. That's the risks. It's not necessary that it develops, but statistically, these are the possibilities. No, they were the estrogen agonists. Okay?
Estrogen antagonists.
Yes, estrogen antagonists. Okay. Or anti-estrogens. No. Estrogen agonists and anti-estrogens.
And?
Anti-estrogens. Anti-estrogens. Okay?
Not true?
Anti-estrogens. Okay? As for anti-estrogens, there are two types of anti-estrogens. Okay? Aromatase inhibitors.
And 5-alpha reductase.
No. 5-alpha reductase is the other side. That's the male side. Okay? Aromatase inhibitors and estrogen antagonists. No, let's see, what is the difference? What is an agonist?
Agonist is
Stimulation. Antagonist block.
Yes. And why anti-estrogens?
Because we don't produce the estrogen.
Exactly. Since aromatase inhibitor is also an anti-estrogen. However, aromatase inhibitors stops synthesis of estrogen, estrol and estradiol. Okay? The aromatase inhibitor stops the synthesis. Okay? Estrogen antagonists are bind to the estrogen receptor, however, no biological response develops. We studied it at the very beginning. Yeah, now you are studying it in pharmacology too. Yes, physiology. Okay, that's why we use anti-estrogens. Okay, anti-estrogens and anti-estrogens have two subtypes. No, let's see that. Antagonists, estrogen antagonists. Okay, this one. Okay, they bind to the receptor, the estrogen receptor. However, no biological effects develop. No, the most known, the first anti-estrogen, okay, the first antagonist, synthetic antagonist was clomiphene. Clomiphene is also a trans-stilbene derivative, you see. However, the OH groups are missing, first of all, okay? And there is a third aromatic ring, if you compare this structure with the agonist. Okay? Now look, this is the agonist. Hydroxyl here, and aliphatic substitution. Okay? This is an antagonist. No hydroxyl here. Okay?
And not
And not aliphatic. However, an aromatic. A third phenyl. Okay, and plus here is an amino alcohol group. So this is clomiphene, and the other derivative is tamoxifen.
Tamoxifen is not an anti-cancer drug.
Yeah, it is.
But now here this is a
Just wait. The story starts here. Okay?
So it started then.
Yes, exactly. So this, at the very beginning of developing of this kind of medications, okay, they realized clomiphene. Okay, they discovered clomiphene. Clomiphene is an estrogen antagonist. What does it mean? Binds to the receptor, but does not have biological effects. Okay? No. Afterwards, several other antagonists of this type were developed. One of them was tamoxifen. Okay? No. And when they started to further study these compounds, they realized that these compounds sometimes act as agonists, sometimes act as antagonists. And whether they act as agonists or antagonists depends on the tissue. The tissue where the receptor, the estrogen receptor, is expressed. So a new term were introduced, okay, which are the selective estrogen receptor modulators. So the selective estrogen receptor modulators are a subgroup of the anti-estrogen, okay, which shows a tissue-specific estrogen agonist and or estrogen antagonist action. Tissue-specific. A newer one of this kind is raloxifene. Okay? Tamoxifen, raloxifene, yeah, clomiphene. Okay, clomiphene is antagonist. Clomiphene is pure antagonist. Its modulator effect is not very expressed. However, tamoxifen and raloxifene definitely belongs to the modulator.
Tamoxifen?
Tamoxifen. Tamoxifen and raloxifene. No, look, these are here. Estrogen antagonists. Okay? So originally, if you go back to history, okay, and read a pharmacology book, 20 years old pharmacology book, you can see clomiphene, tamoxifen is estrogen antagonists. Okay? That was the first action which was discovered. However, later on, it turned out that they are not act as antagonists in each tissue. However, there are tissues in which they act as antagonists, and there are tissues where they act as agonists. Okay? No. This is raloxifene. Raloxifene is very much the same. You see, here is one aromatic ring with hydroxyl, then other aromatic ring with hydroxyl, a third aromatic ring with the amino alcohol. No. No, here is the two selective estrogen receptor modulator, tamoxifen and raloxifene. I will translate this text for you, but I think it's understood. No, here are the three tissues: breast, the bone, and the uterus. Uterus is the...
What is the bone in Hungary?
Bone is joint.
چند شروع شد
Bone density.
بوند
Bone density. Yes, chond shurishik density. No. Since this is the three main sites, okay, in the body where estrogen receptors are expressed in high concentration. Okay? These are the three main sites in the body where estrogen receptors are expressed. The bone, the breast, and the uterus. Okay? Now, what is the function of the estrogen in the uterus? In the uterus, plays a very important role in development of the babies. You know. Okay? In the bone, it plays a very important role in keeping the bone density. Yeah, you know the bone. You have heard about the bone? The bone is continuously synthesizing and
in the old age it is not produced.
exactly. And when there is no enough estrogen, you know, the bone density is falling down. That's why estrogen substitution should be used for women. Since if there is no estrogen substitution, the bone density is falling down.
Easily break.
Exactly. So the problem is with male and female that the bone density is continuously increasing up to 22 or 24. And from 24 on, the bone density is declining. Yes. The only question is that this decline okay, is so steep or a little bit slower. It depends on you, your lifestyle. Okay? So, for example, if you drink lots of Coca-Cola, it makes drop of bone density faster. That's why Coca-Cola is not very
Milk.
yeah, milk is used. Milk is no, okay. And the breast, the problem is in uterus and breast with the substitution that there are types of cancers. Okay? There are two types of breast cancers and uterus cancers. In one type of these cancers, in the cancer cells, the estrogen receptors are still expressed. These are the estrogen plus cancer cells. And there are another type of cancer cells in which the estrogen receptors are not expressed. Okay, that's the estrogen minus cancer cells. And in such a case, first of all, the medical doctor should determine whether a breast cancer or a uterus cancer is estrogen plus or estrogen minus. Okay? In case of estrogen plus, the estrogens, okay, makes development of the cancer and makes the cell cycle faster and faster. So in this case, application of estrogens is not desired, since estrogens makes development of the carcinogenesis faster. So in this case, anti-estrogens are very useful to slow down or stop development of cancers. That's why tamoxifen is used. Since tamoxifen in the uterus, in the breast, is an antagonist.
Other organs, yeah?
Yes. So tamoxifen and raloxifene, okay, are the vast combinations of receptor estrogen modulators. Why? Since in the uterus, both of them are antagonists. Because they are antagonists, okay, they prevent the natural oestron, estradiols, effect on the carcinogenesis. Stops, prevents it. That's why tamoxifen is definitely used as chemopreventive agent to prevent development of breast cancer. Okay? That you said anti-cancer agent. That's it. However, in such a case, in estrogen minus cancer cells, they don't no use, obviously. Okay? In the bone, both compounds are agonists. Oh, it's very good since they help keeping the density of the bone. Since in the bone they are agonists. Okay? And in the uterus, tamoxifen is not very strong agonist. Okay? However, raloxifene is definitely antagonist. So this is the selective estrogen modulators.
How different between two tissue organisms? Receptor is changed.
Yeah, the receptor is. I will show you. Okay. Okay. You have studied about the steroid receptor, don't you?
What do you want?
What is the? No, the book. May I ask you to ask the secretary to bring in the pharmaceutical chemistry book.
Both sides are kept. Almost both sides. Can I ask you?
She can speak English. Everybody studies in English.
Secretary?
Every secretary in the building.
Really?
Yes. Every technician.
You mean this?
No. The journalistic thing, yeah. Today?
No, every day.
Every day.
With everybody.
With everybody?
I think she has some problem at home. Because she's so depressed, she's like...
But she's working very hard.
Really?
Yeah, sometimes I also say.
I just feel one time she's happy and she has fun. She's always sad.
No. So this is the mechanism of action. So here is the cell. Okay, this is the cell membrane. Okay. Here is the steroid. The steroid is coupled with the protein, the receptor protein. Okay. And the so-called heat shock protein is dropped. Just dropped. Okay. And the ligand, I mean the steroid, binds to the receptor. This is you see? No.
Okay.
The ligand receptor complex undergoes dimerization. The dimer is formed. See? Okay. And this dimer gets into the nucleus.
Just like that one?
No. This is chemical.
Gets into the nucleus. And it binds to a special part of the DNA. This is the estrogen.
Element response efficacy.
Yeah, that's it. Okay. So when it binds to DNA, okay, transcription starts. Okay. and messenger RNA is formed, and based on this messenger RNA, a protein is synthesized. Okay? The protein can have physiological function inside the cell and outside the cell. Okay? No. However,
The protein?
yes, protein. You see, however, this binding, okay, is a very complex, okay, and it not only the receptor complex should be bind, however, several other compounds, transcription factors, which are necessary to bind to this area of DNA, and if those compounds are not expressed in very high concentration in one particular cell, this program doesn't start. Is okay? So, yeah. So that's the answer to your question. Okay? No. And the other type is aromatase inhibitors. Okay? Anti-estrogens, estrogen antagonists. Okay, no, we are talking about aromatase inhibitors. What aromatase do? Aromatase oxidize androstenediones ring A. Okay? Aromatase is a cytochrome P450 enzyme. Okay? The mechanism of action.
Aromatase is cytochrome P450?
It is a cytochrome P450 enzyme.
The aromatase.
The aromatase. What's the problem?
Because the CYP is just for the metabolism, something like that.
Yeah.
Now the aromatase is CYP.
It's CYP. But each CYP, lot of CYP has got trivial name.
Trivial name, aromatase.
Yeah.
Yeah.
CYP is the official name, you know, like in the organic chemistry.
Yes, get it understood.
Okay? Tyrosine hydroxylase is also a cytochrome P450 enzyme. Okay? Cytochrome P450 means the structure. You know? You remember the structure of cytochrome P450?
Yes.
What is it?
It has a one cycle.
Yeah.
The structure or the cycle?
Yeah, the structure.
The structure. It has a maximum absorbance at the 450 nanometer.
Yeah, but what is the structure?
It's a protein enzyme.
It's not a protein. Yeah, it's a protein, but not a simple protein.
Very complex.
Yes, it is an iron containing enzyme.
And it has a porphyrin.
Yeah, it has
It has
a
cytochrome
ham.
reductase.
It has a ham part. The ham part binds to the protein, okay, through a sulfur amino acid, okay, and positioned somewhere in a very lipophilic part of the protein. And it's not enough, okay, since besides the cytochrome P450 enzyme, we need a complex, a cytochrome P450 reductase, and choline. And these three forms a complex, and this complex acts as an oxygen activator. In a way, they activate molecular oxygen, and they introduce one oxygen atom into the substrate. This is the cytochrome P450. Okay. However, so this is the structure and the function and the mechanism. However, a lot of them has got trivial names. For example, tyrosine hydroxylase, okay, aromatase. The trivial name expresses the function of the cytochrome P450. Okay? There are a lot which do not have special names. Cytochrome P450 1A1. Okay? Good? Understood. Very good. No, okay. Now here is, there are two types of activators. Okay? Here is the enzyme, the cytochrome P450. Here is the aromatase, the protein itself. Okay? And there are two types. The type 1, okay, the type 1, which are steroids, okay, and type 2, which are non-steroids. The steroids, okay, the steroid aromatase inhibitors, okay, binds to the place of androstenedione.
That's right.
The steroid type inactivators, okay, binds to the place of androstenedione. Okay? So replace the natural substrate, which is also a steroid. Is it okay? Since androstenedione is the natural substrate. So one of the inhibitors are steroids. The other type of inhibitors are non-steroid inhibitors. Okay? The non-steroid inhibitors bind to the protein. Allosteric inhibition. Have you heard about it?
Not
Yeah.
to the active site.
Not to the active site, but to the other. So the steroid inhibitors bind to the active site. Okay? The non-steroid inhibitors are allosteric inhibitors. They bind to the protein, conformation change, and the enzyme does not operate any longer. Is it okay? Not very good. Now let's see. And type 1. Type 1, the steroids are androstenedione derivatives. Okay? Since androstenedione is the natural substrate. You see, here is 4-methane, which is 4-hydroxyandrostenedione. Okay? And here is hexamethane, which is a little bit more different than androstenedione. However, it also resembles the structure of androstenedione. This one. So these are the type 1. Okay? The type 2 are typically triazole derivatives. Okay? Diazoles or triazole derivatives. Fadrozole, anastrozole. Okay? You see, here is a diazole or a triazole. These compounds bind to the hand. This is anastrozole. These directly binds to the iron of cytochrome P450. Binds by means of the nitrogen. Okay? And they bind to iron so strong that iron cannot bind oxygen. If iron cannot bind oxygen, it cannot activate oxygen, and no active form of oxygen form, no hydroxylation occurs. So they do not operate any longer. Okay? Yeah, sorry, I missed that. The type 2 are not to the proteins, but to the iron too. So the type 2 inhibitors, the non-steroid inhibitors. Okay? Sorry, they bind to not to the protein. Sorry.
Did they bind to iron?
Bind to iron of the hand.
And not allosteric?
Not. Sorry, I'm just somehow mixed up. Just iron. Just eliminate that. Is it okay? Is it okay?
Yes, it's understood.
Very good. No. And there are different generations of these aromatase inhibitors. These are the type 1, okay, the type 1 steroids, and the type 2, the non-steroids. So, for example, aminoglutamide was the first generation non-steroid inhibitor, which is also an amino compound. Okay. Fadrazole, and now the most used inhibitors are gorazole, anastrozole, letrozole, for those nitrogen-containing 5-membered heterocyclic rings, the azole types. Okay. And hexamestane, 4-mestane, hexamestane are those derivatives.
Okay.
Okay?
Pharmaceutical means both of them?
Third. Ershö means first generation, Második means second generation,
Okay, understood.
Harmadik means
The new
third
generation.
generation. Types, type 1, type 2, first generation type 1, testosterone, first generation type 2, aminoglutamide, second generation type 1, 4-mestane, second generation type 2, fadrazole.
Get it.
Got it? Okay. Androgen.